Hey, what up, guys? This is Ryan with Brainstorm. So, the concept of a unit rate, right, all of a sudden in this lesson merges with the slope of a line. And so here we have three things. We have a table of kind of values, and then we put it into an XY table, which kind of represent we're going to find slope, and then we can actually show it graphically. And these three things are all related, and they kind of come together in this lesson. And the unit rate is this. So here we have something like hours and miles. Like, this is me driving. I go 60 miles in 1 hour. I go 120 miles in 2 hours, and I go 180 in 3. And you can quickly, from past lessons, understand that this is probably linear because look, aren't I adding 60 to get from 60 to 120 plus 60, and then I add 60 again to 180. So I know this is linear, right? I can tell right away. But one thing we want to find from the table is we want to find the rate. What is the rate at which I'm traveling? And you might look at it and go, that's obvious, man. You're going 60 miles an hour. It's not always that obvious, and there's an actual formula to calculate it. And what it is it's change in y. So the formula to find the unit rate is the same as the formula to find slope, and you'll see it graphically in a minute. I'll show you the slope formula first. It's the change in y over the change in x. Triangle means change. But better put, it's y2 minus y1 over x2 minus x1. That's very confusing. You shouldn't even understand what I meant. But here's what it means. Notice the y's are on top. That's these values here. And the x's are on bottom. These value here. So we can consider these sort of y's and x's even though it's miles and hours. And so what you do is you go second y minus first y. It's this guy minus this guy, so let's do it down here. 120 minus 60 over x2 minus x1, right? So second x minus first x, so that'd be 2 minus 1. So again, him minus him over him minus him. And that's how you get your unit rate. So that would be subtraction, that'd be 60 over 1. So my unit rate is 60 miles over hours. So this would be, my rate is 60 miles per hour, right? And the cool thing about unit rate and slope is this. When I chose my y2 minus y1, I said him minus him over him minus him. It works for any y minus the other y as long as you do x minus the other x. So for example, watch this, right? What if I use the same formula, but I did these 2 points? These are points, xy, xy. This is sort of xy, xy. What if I did him minus him, 180 minus 120 over him minus him, 3 minus 2. Notice I get 60 over 1. You get the same unit rate no matter what. What if I did this guy minus the top guy, right? What if I did, 180 minus 60? I went all the way from him to him over 3 minus 1. That would be, looks like 120 over 2, which is again 60, my unit rate. Is that crazy? So what I'm doing when I'm finding the unit rate is it's the exact same thing as finding the slope, which will show up on a line. So watch. Okay, I just moved that over to give myself some more space. So remember, the way to calculate the slope or the unit rate was change in y over change in x, y2 minus y1 over x2 minus x1. Really, this is last y over first y over last x minus first x. So again, let's do him minus him, 120 minus 60, y minus y over 2 minus 1. Hey, sure enough, I get 60. And I won't even do it because if I did the difference here, it would be 60 over 1, or the difference here would be 120 over 2. And so now we know that the unit rate is the exact same thing as the slope. And now, what does that look like visually? Check this out. If I graph these 1, 60, right? I went over to 1 and I went up 60. I made each of these 60 to make it easier on myself. Otherwise, this would be like a mile high. But I went 1, 60, 2, to 120 and 3 to 180. First of all, you notice it's linear, which makes sense because the rate of change is the same. But you can also find the slope by looking at this graph. And if I could find the slope, that's the same as the unit rate. And one thing that's cool is this delta change in y over change in x is also displayed as y2 minus y1 over x2 minus x. It's also called rise over run when you look at a graph, which makes sense. How much does it go up over how much does it go to the side, right? And if you look at this, how much does it rise? If I went from this point to this point, I went up a ways and over a ways. How far up did I go? It looks like I went from 60 to 120. So I rose 60 and I ran to the side from 1 to 2, 1. And there, sure again, shows up was my slope. Is that weird? So basically what you're learning in this lesson is that unit rate in some word problem, like how far I drove, is the same as the slope of a line. And here's the three ways to look at it. Unit rate also could be represented as XY values, input, output, input, output. And you can see it as rise and run over the table. I know that's crazy, and this is probably the first time you've heard it. So let's do a couple little problems. Okay, so here's three problems. And I might say find the unit rate or slope of this guy, right? And what is that? Remember, it's y minus y. First of all, they should tell us if it's proportional, but I can check. This goes up by 5. Wait a minute, this one's a trick question. This is a 12 here, and this is a 23. Okay, so wait a minute, we messed this up. All right, there you go, I fixed it. Okay, so this goes up by 5, up by 5, up by 5. Sure, it's proportional. Now, one thing that's weird is you can't just say this goes up by 5, so the unit rate is probably 5. But be careful, that's cheating because these go up by 1. Look over here, they don't go up by 1, 2, 4, 6, 8. They go up by 2, so don't get cocky. Do the actual formula. y2 minus y1 over x2 minus x1. That would be second y minus first y, 7 minus 2 over second x minus first x, 5 minus 4. And yes, okay, so you were right. Congratulations. It's 5 over 1, but we had to make sure. The unit rate is 5 over 1, or just 5, of course. The slope is 5, and the rise over run is 5 if I graphed it. Okay, look at this guy. Now this one, again, this is a little weirder because up by 4, up by 4, up by 4, but over here is up by 2, so don't get cocky. Pick 2 points. You could use the first 2, the last 2, any 2. All right, just to be fun, why don't we just pick these 2? I'm going to go y minus y, 16 minus 12 over 6 minus 4, right? And that would looks like 16 minus 12 is 4 over 2. So my unit rate is 2, or my slope is 2, or my rise over run is 2 over 1. Is that weird? Now the third case, they didn't give us a table. They just gave us a graph and said, find the slope of this graph. And I know that looking at this, the slope is rise over run. How far did it go up to get to here? And how far did it go over? And this is the rise divided by the run. It looks like my rise went up 1, 2 over my run went just 1. So my slope there is 2 over 1. Hopefully that makes sense. I think what's weird about this lesson is that you're converting two things. You're converting unit rate from like a word problem, like Billy rode his bike 10 miles and it took him 40 minutes, right? And you have a real life scenario that gives you a rate, which we know now is the same as a slope of a line, and that can be represented with tables or visually. And this is your slope here, rise over run, which you got from your slope, which you got from your unit rate from a word problem. All right, hopefully that makes sense, you guys. Good luck in this section.